In this video, we're considering how to control a motor using a microcontroller and an integrated circuit. We've already looked at the pinout of the integrated circuit and how to connect it to pins on an Arduino Nano, and let's revisit that now. We're going to need to look at a specific chart. So here's the chart that we have. And just to review, this is showing the pinout for an L293 motor driver integrated circuit, and we want to connect it to a single motor that runs off direct current, and we're going to need to connect 9 of the pins to various things. So what we want to do, as you can see from this diagram, is we want to connect pins 8 and 16 to 5 volts. We want to connect pins 4 and 5 to ground, pins 3 and 6 to the DC motor, and then we want to connect pins 1, 2, and 7 to digital pins. They're going to be digital output pins, and the digital output pin that we select for pin 1 needs to be one that supports pulse width modulation. So we'll connect all these pins on this integrated circuit to the Arduino Nano. And then once we've done that, we want to start thinking about how we're going to program this thing. So let's go into a terminal window and fire up the Arduino IDE. And launch it like this. In fact, just want to focus on this for the time being. Okay, we'll put these, I'd like to make it so we can see both of these things because we'll want to refer to both the pinout and the IDE, the sketch that we're going to create. So in working with this, we're going to start with a new sketch. So I'll go to the menu here and choose new. Okay, and then it's going to give me a template that I can use to work with. So I'll just make it a bit larger. Okay, and as usual, we're given the structure for setup and loop, and we can put in here what we need in order to make this all work. So let's start by considering the pins that we need to control. If we look at the pinout, we see that we have to pick those 3 digital output pins. So what I'd like to do is just at the beginning, before the setup structure, I'd like to put in some definitions. I'd like to specify which pin I'm going to connect on the Nano to EN1, which one I'm going to connect to IN1, and which one I'm going to connect to IN2. They're all going to be digital pins. So let's just say that I pick pin 3 for EN1. Okay, that's a pin that supports pulse width modulation, and I'm going to specify it as an integer. So I'll put int at the beginning, and then I have to close it off with a semicolon so that it's a properly formatted statement. I'll do the same sort of thing with IN1. I'm going to choose digital pin 5 for this one. And then IN2, I'm going to pick digital pin 6 to make this work. Okay, so I have all my digital pins selected. Whoops, I had to put in the right syntax for all these guys. Okay, I've got IN1, IN2, EN1. Okay, and they're all specified now. I've stated which of these pins I want. They're all digital. Then within the setup structure, I need to put in how I would like to use these digital pins. I want to set them all to be output pins, so I have to specify pin mode for each one. So if I talk about pin 3, that's the one I'm using for EN1 that will control speed. That's going to be an output pin. And so is Whoops, you know what? I just realized I don't want to use pin 3 explicitly here. I want to use EN1 because I might decide to use a different pin. And I only want to change that value in one place at the beginning of the definition section. Then IN1 is also an output pin. And then IN2 is an output pin as well. Okay, so I've got all three of those specified. And the other thing that I would like to do, actually I would like to put a comment in to talk about what I'm actually doing here. Set all motor control pins to output pins to output. Okay. And then the other thing that I'd like to do here is I want to turn off the motor just to start things off. Just in case it's moving for some reason. So to do that, the easiest thing for me to do is just to send low, set pin in1 to low, and set pin 2 in2 to low as well. Okay, that's one of the ways that I can turn off the motor. Set those both to low. Okay, now within the loop, this is the code that is going to run repeatedly. Now, I haven't really talked about what exactly I want this motor to do. What I'm going to do is pretty simple. I'm going to make the motor run at maximum speed. And the way that I do that, the speed control is at the EN1 pin. Okay, so what I'm going to do is send that value, that maximum speed value, to that pin. So I have to use analog write for this. And the pin is EN1. And what I'm going to send it is the highest possible value at which the motor can run, which is 255. Okay, because that corresponds to an 8-bit register with all bits turned on. 255 is the 8 bits, the 8 binary digits, all ones, and it means that it's 255 in base 10, so that's how I say go at maximum speed. So I've specified that I want to go at maximum speed, and then the next thing I want to do, I guess what I'll do here is I'll just say set speed to maximum, set speed to max value. Okay, and then the next thing I want to do is I want to turn on the motor. All right, and I want to make it turn it clockwise. So the way that I can do that is by typing digital write, and I can make IN1 high. Okay, and at the same time, oops, I have to fix digital write on the line above. I messed up. It has to be capital W. Digital write IN2 has to go to low. Okay, if they're different from each other, then the motor is going to turn. And this is the way that we make the motor turn clockwise. Now, I want to have it run, and I'd like it to run for 2 seconds. So I'm going to put in a delay of 2,000 milliseconds. Okay, and that will give it enough time to get up to that high speed, I think. Now, I want to then make the motor turn counterclockwise. Okay, and so to make it do that, I have to run it in the opposite direction. So to do that, I make the value, this is the value I send that I write to IN1 is low. And then I, at the same time, digital write, IN2 will be high. Okay, now, once I do that, I'd like to give it a chance also to get up to speed, so I put in a 2-second delay. So the way that this is going to work is I'm going to have the motor turn clockwise for 2 seconds and then counterclockwise for 2 seconds, and then it's just going to keep doing that until I'm done. Now, this is a very simple sketch. I just want to make sure that it compiles. Let's go ahead and compile it. Okay, it wants me to come up with a name for it. Okay, I'm going to call it motor 2, and that's it, motor 2. Okay, so the sketch compiles. Okay, and then I just want to talk a little bit about this. This sketch is really simple. Okay, it doesn't have any variation in speed. I have analog right. I'm just setting it the maximum value, and the only thing that I'm changing as the sketch loops is the direction in which the motor turns. Now, the reason I put the delay in is because each of these instructions only takes a few microseconds to execute. So if I don't have the delay, the motor is never going to really have a chance to do much of anything, because it's going to be going back and forth between these two directions so quickly. So the delay will allow opportunity for the motor to change direction and probably get up close to the maximum speed. We can experiment a little bit with the delay that we use it for this. So the direction is changed each time we go through the loop, but the speed is not. Now, there are ways that we can control the speed by varying the value that is put in here that is sent. Okay, we could set the speed to something else that could vary. It could be that we could have it go along with a voltage that is read at an analog pin that could be controlled using a potentiometer. That's a more complex sketch. I haven't written anything like that, but that's something that you as a user can experiment with. So this is a pretty straightforward thing to hook up. You just have to select the 3 digital pins. You have to make sure that the pin that you connect to pin EN1 supports pulse width modulation. And then after that, this sketch will make the motor turn as stated, but it's just a starting point for you to make other things. You could modify this sketch to do a variety of things. You would probably have to modify the way that you have the chip connected to various hardware. This is really simple because all you have to do is make sure that you connect the pins as stated here. There are no resistors or any other devices that are connected. So this is pretty simple. You can come up with something more complicated if you wish, and you can just play around with it on your own.